we will see that it's hard to find a change that doesn't have an impact on something other than the desired one. We're just going to look at 3 scenarios which explore further the single-step operation of the previous examples. The last couple of exercises looked specifically at capacity. We saw that it's hard to alter capacity without affecting other measures. We now look at all kinds of change that may affect any or all business measures of cost, inventory, time, and capacity. First of all, let's go back to the batch size question. Let's change batch size from 2500 to 1500. If we look at all the outputs, everything has changed. Making smaller batches increase costs. We'll look at that in detail again. It changes inventory in a positive and negative way. Different types of inventory go up and down. It affects response time and lead time, and it affects capacity utilization. So let's just go through that one at a time just to try and understand what's happening here. First of all, material cost has gone up. In fact, if you compare that $41,000 with the $460,000 on the left-hand side, it's gone up about 10%. The reason it's gone up 10% is because the extra batches that we now have an additional amount of waste associated with them, because we had a fixed batch waste quantity. So we're now wasting more. That's what that material waste is. And because we are wasting more, we are actually processing more, so we need more labor to process it with. So that's what the $32,000 figure means. And because there are more batches, there are more batch-related costs, so that's what the $6,000 figure means. And then looking at the raw material, that number goes up because raw material is measured in days quantity, not units. So because we're using more material to make the same amount of output, the same number of days worth means there's more material. So the raw material stock goes up slightly, whereas work in progress goes down because we spend less time to process all the batch, which is why lead time goes down by a day. For finished goods stock, there are a couple of conflicting effects. First, the smaller batch means that the average quantity held is less. However, the value of the material held increases because of the extra amount wasted. The result is no real change. Overall, as we've said before, it's debatable whether inventory went up or down depending whether you look at the material only value or the fully burdened value. Response time comes down a lot more than lead time because the more frequent batches, which the smaller batch size means that they come round again faster, so the period between batches is much less. The capacity utilization goes up because we said we are processing more material. In fact, you can see that 8% is about 10% of the 77%, which corresponds to the 10% extra material that we're processing. So we're processing more material, which ends up getting scrapped. So there we have probably the biggest lever for change within an organization, but a dangerous one. So let's move on to another example. I'm going to leave batch size at 1500. And now let's just look at machine speed. Let's increase the machine speed, not to 4 this time, let's go up to 3 items per minute, so it's a 50% increase. What happens here? We're still wasting that material because of the extra batches, but that's more than compensated for, in fact, by the higher productivity of the labor that's running the machine. We're still losing money on the batch changeovers as before because there are the same number of changeovers. But overall, we have a cost saving. On the inventory front, the same thing applies, although the work in progress number has got more favorable. In other words, not only are we making smaller batches which take less time, we're doing them faster, which takes even less time. So the lead time difference is now 2 days less, and the assembly area capacity utilization has gone down now because we're processing much faster. Overall, the combination of that batch size change and that machine speed change, you could say that is an improvement. We have saved cost, we're pretty well neutral on inventory, we have saved time, and we have saved capacity. So that is definitely an improvement. We're now just going to do something different. This is something that's usually outside the control of manufacturing, which is an influence of marketing. They want to make the same output, the 250 items per year output, they want to sell that number, but they want to introduce a variant. So 20% of those are going to be something else. So we have a tab here called Variance, which we haven't looked at before, which has a list of the product variants. At the moment we just have one, item A, which has got a sales volume of 250,000. We're going to change that to 200,000 of item A and introduce a new one with 50,000 in it. The total is still 250,000, but we've got the extra product. Go to the output sheet. You can see that this has the effect of doubling the product related expense, which is one of the overhead categories that we talked about. So we've added some cost, and because we now have a second product that's been made, the response time has increased. The lead time is still the same, still takes us the same amount of time to make the batch, but the batches of the same product come round less frequently, and as a consequence of all of that, we've also increased the finished goods inventory. The capacity utilization remains the same. So making the same volume with an extra product variant has a cost implication and an inventory implication and a response time implication that we don't really like the look of. If the volumes had changed, let's see what happens now. Suppose that item B wasn't cannibalizing item A but was an additional to it. Let's leave item A at 250,000, so the total volume is now 300,000. Let's take a look at what that does. Well, you can see here that the costs have gone up. Obviously there's more material being processed, but the unit cost has come down. So making extra volume, we have brought the unit cost down. We've still got inventory going up for the reasons we've explained. The response time has still gone up, but not as much as it did before. And clearly we're making more products, so we need a bit more capacity for it. And at 82%, that's pretty much on the borderline of what you would normally consider acceptable capacity utilization. For your information, those three scenarios are numbers 18, 19 and 20 from our book Bridge of Faith for Operations.